Assalamualaikum. This is 12th chemistry, and our today's topic is about the this preparation of these amines. Now we have already discussed the types of amines, and we also discussed their nomenclature. Now, as far as their preparation is concerned, we have got a number of methods that are used for the synthesis of these amines. Like the first method, we have this from alkyl halides. So the first method that involves the ammonolysis of these alkyl halides, and what we see, this reaction is a Hoffman's method. In this method, an aqueous or alcoholic solution of ammonia is treated, or it is heated with alkyl halide at a temperature of 373 Kelvin in a sealed tube. Now, in this method, all the three types of these amines are obtained: primary, secondary, and we get a mixture of these three types of amines, that is primary, secondary, and tertiary amine. Now, and this reaction is called as ammonolysis. It is called as ammonolysis. Now, in this method, you can see here, I have shown here, this is methyl iodide. When it is treated with this alcoholic, this solution of this ammonia, it gives first a primary amine. This is methyl amine, and this methyl amine then reacts with another molecule of this methyl iodide. It forms then a secondary amine. This is dimethyl amine. And now, similarly, this dimethyl amine then again combines with another molecule of this methyl iodide to form trimethyl amine, that is a tertiary amine. Now the tertiary amine that is formed, it may combine with another molecule of this methyl iodide to form a quaternary ammonium salt. You can see this is a tertiary amine, trimethyl amine. It reacts with another molecule of this methyl iodide to give this is tetra methyl ammonium iodide. Now, this is a nucleophilic substitution reaction in which we see ammonia, or this amine molecule, it acts as a nucleophile since it has got a lone pair of electrons on the nitrogen atom. And as far as the order of reactivity of this reaction is concerned, we see this alkyl iodides, they are more reactive than alkyl bromides, which in turn are more reactive than alkyl chlorides. Then this is the first method, that is which involves the ammonolysis of these alkyl halides. Then we have got another method, that is Gabel's phthalimide synthesis. Now, this is a well-known reaction, and this reaction is used for the synthesis of these primary amines. So this is used particularly for the synthesis of these primary amines. And in this method, what we do is, or what we see in this reaction, as I have told you, that it is used for the synthesis of this primary amines. And in this method, we see phthalimide. It is treated with alcoholic potassium hydroxide to give potassium phthalimide. You can see this is a phthalimide. It is treated with this alcoholic potassium hydroxide, and it gives potassium potassium phthalimide. Now, this potassium phthalimide is then treated with an alkyl halide molecule to form an alkyl phthalimide. You can see here, this is potassium phthalimide, which is got when this phthalimide is treated with alcoholic potassium hydroxide, and this potassium phthalimide is then treated with this alkyl halide molecule. I have shown here, this is ethyl bromide, and it gives an ethyl phthalimide. Now, this n-ethyl phthalimide, it is then subjected to a hydrolysis, or it is refluxed with this with 20% of this HCl under a pressure, or it is treated with this sodium hydroxide to give a primary amine. You can see here. So this is when it is subject to hydrolysis, this n-ethyl phthalimide. It is then treated with this, or it's subject to hydrolysis, or it is treated with a dilute HCl, and we get this is a primary amine. This is ethane amine, and phthalic acid is it is again then it is rather regenerated. Now, this phthalic acid it can be then again converted into this Thalamide. Again, it can be converted into this thalamide, this salicylic acid, and it is used again and again. So, the amine obtained in this method, it is a pure one. That is, pure amines are got in this or produced in this reaction. Then we have got another reaction, that is the reduction of nitriles. Now, this is the second another method which is used for the synthesis of these amines, and this that is the reduction of nitriles. And this reaction is known as Mandes reaction. So, what happens in this reaction? Alkyl these cyanides or alkane nitriles, they are reduced with hydrogen in presence of nickel or platinum, or we can use lithium aluminum hydride as a reducing agent, or we can use sodium. We can use sodium and ethanol. Now, you can see this is to get since we get primary amines in this method. This is nitrile molecule. This is ethane nitrile, or it is methyl cyanide. Upon reduction with any of these reducing agents, we get this is ethane amine. Now, or it is called aminoethane. Similarly, this is benzonitrile or cyanobenzene. When it is reduced using these any of these reducing agents, we get this is benzyl amine. So this is another method that is used for the synthesis of these amines. Then we have got another method, that is by reduction of amides. Now, in this method, these amides, they are reduced to their corresponding these amines by reducing them with lithium aluminum hydride, or we can use sodium and ethanol. You can see this is an amide. It is ethanamide, or it is acetamide, and when it is reduced, it gives ethyl amine or ethanamine plus water. Again, this is benzamide. When it is subjected to reduction in this method, we get this is benzyl amine, or we can use formamide, this or methanamide. Upon reduction, it gives this methyl amine plus water. So this is another method. Then we have got one more method, that is by reduction of oximes. Now, these primary amines, they are also obtained, can be also got from these oximes by reduction by reduction of these of oximes of these aldehydes and ketones with sodium and ethanol or lithium aluminum hydride. And you know that these oximes, they are got by treating aldehydes or ketones with hydroxyl amine. And I have already told you about this reaction while studying the chemical properties of these aldehydes and ketones. Now, this is an oxime. This is aldoxime plus when it is reduced using this reducing agent, the lithium aluminum hydride, or we can use sodium ethanol, we get a primary amine. This is an amine, and plus water is also formed. Now, this is ethanol oxime. You can see here, upon reduction, it gives ethyl amine. Similarly, this is an acetone oxime. Upon reduction, it gives this it gives us a again, this is a primary amine. This is a primary amine, or its UPAC name is 2-aminopropane plus water. Then we have got another reaction that is called as Hoffman's bromamide reaction. Now, it is also called a Hoffman degradation method. Now, in this method, these primary amines, they are prepared from these amides by treating them with bromine and KOH, potassium hydroxide. The amine formed in this method contains one carbon less than the parent amide. Now, you can see this is acetamide, or it is ethanamide. When it is treated with this bromine and alcoholic, this KOH, potassium hydroxide, at a temperature of 343 Kelvin, we get methyl amine plus potassium bromide and potassium carbonate and water. So the amine that is formed has got one carbon less than the parent amide. Now, you can see again, this is benzamide. When it is treated with this subjected to this Hoffman's degradation method, and we get this is aniline, potassium bromide and potassium carbonate plus water. So this is another method. Then we have got one more method, that is by the reduction of the nitro compounds. Now, in case of in this method, we see that these amines are also got. They are also got by the reduction of these. They are by the reduction of these nitro compounds with reduction with hydrogen plus of nickel, or we can use this platinum, or we can use this palladium, palladium, or we can use lithium aluminum hydride, or we can also use this and we can also use this this we can also use this tin and HCl, or we can use iron and this we can use iron and this iron and HCl. Now in this method you can see here, this is a nitroethane, or or we can call it as this is ethane nitrite, and uh, when it is subject to reduction in presence of this it is subject to reduction in presence of these any of these reducing agents, that is tin HCl, or we can use this iron and HCl, or we can use nickel palladium or palladium as catalysts. These nitro compounds, they get reduced to the amines. You can see this is nitroethane. When it is reduced, it gives ethyl amine. Similarly, this is a nitrobenzene. When it is reduced, it gives aniline plus water. So this is another method. Then we have got a few more methods. We have got industrial method. Now as far as this method is concerned, in industrial method, what we do, you can see here, I have shown here, this is an industrial method. In this method, these lower aliphatic amines, we see they are generally manufactured by passing a mixture of alcohol and ammonia over heated alumina. You can see here, this is ethanol and ammonia. They are passed over this heated alumina, and we get ethyl amine plus water. Then we have got one more method, that is by the action of Grignard's reagent on this chloramine. You can see here, this is ethyl magnesium iodide plus this is chloramine, and it gives when it is treated with this chloramine, it gives this is ethyl amine. Then we get this is chloromagnesium iodide. Then we see then we also